So in this presentation, I'll be talking about 8251 Universal Asynchronous Receiver Transmitter. The subject is Microprocessor TCS 403. My name is Gaurav Parashar from the Computer Science Department. The contents of the presentation are, I'll be talking about the introduction of USART, we're talking about the pin diagrams, and the clock number. Now let's understand what exactly is 8251. 8251 is a programmable serial communication interface chip designed for synchronous and asynchronous serial data communication. It supports serial transmission of data and it is packed in 28-pin dual package. Now this is the pin diagram. Now, as you could see over here, that there are 28 pins, and these pins starts with Ds. So these Ds, D0 to D7. Okay, these are 8 data pins, and these are used for the parallel data transfer. Now let's talk about C oblique D bar. This is used for control register or the data buffer select. Then you have RD bar. RD bar is used for read control. WR bar is for write control. CS bar is for chip select. CLK is for clock pulses. Reset is to reset the 851A. TXC bar is transmitter clock. TXD is transmitter data. RXC bar is receiver clock. RXD is receiver data. RXRDY is receiver is ready. TXRDY is transmission ready. DSR bar is data set ready. DTR bar is data terminal ready. Sync detect is synchronous detect. PRK is break detect. RTS bar is request to send data. CTS bar is clear to send data. TXMT is transmitter empty. This is VCC and this is ground. So these are the names of the pins which are there in 8251A. We'll be discussing about the details of each of every pin in the block diagram. Now this is the block diagram of the architecture of 8251. Let me explain you exactly what happens in this architecture on the diagram. Now, to start with, this is the read and write control logic. What it does is that it helps the USART, Universal Synchronous Universal Asynchronous Receiver Transmitter, so 8251. So this chip select is used to select or deselect this 8251. RD and WR are the read and write pins. C or D, as already mentioned, is for control and data select. This is the clock. We are sending the clock to this 8251, and this is for resetting the 8251. Now, DSR, DTR, CTS, and RTS are the modem control. Now, modem control is used for serial data transmission. There, we have the data buffer. So the data buffer is used for the transmission and receiving the data from the channel into the channel. Now this portion is transmitter. This portion is the receiver. So if you want to send information, so you will use this particular area, and for receiving, you will use this particular area. Now to understand the architecture, we have divided this architecture into 5 sections, and they are read and write control logic, transmitter, receiver, data bus buffer, and modem control. Now, what happens in a read and write control logic? Now, when C oblique D bar is high, the control register is selected for writing the control word or reading the status word. When C or D bar is low, the data buffer is selected for read and write operation. When reset is high, it forces 8251A into the idle mode. The clock input is necessary for 8251A for communication with the CPU, and this clock does not control either the serial transmission or the reception rate. Now coming to the transmitter section accepts the parallel data from the CPU and converts them into serial data. The transmitter section is double buffered. That is, it has a buffer register to hold 8-bit parallel data and another register called the output register to convert the parallel data into serial bits. When the output register is empty, the data is transferred from buffer to the output register. Now, the processor can again load another data in the buffer register. If, say for example, if buffer is empty, then TXRDY goes high, and if the output register is empty, then TX empty goes to high. The clock signal controls the rate at which the bits are transmitted by the 8251. The clock frequency can be 1, 16, 64 times the baud rate. Now, if we talk about the receiver section accepts serial data and converts them into the parallel data. The receiver section is double buffered. It has an input register to receive serial data and convert to parallel, and a buffer register to hold the parallel data. When RXT line goes low, the control logic assumes it as a start bit, waits for the half a bit, and then samples the line again. If the line is still low, then the input register accepts the following bits, forms a character, and loads it into the buffer register. Then the CPU actually reads the parallel data from the buffer register. When the input register loads a parallel data to the buffer register, RXRDY line goes high. The clock signal RXC controls the rate at which the bits are received by the USART. During the asynchronous mode, the signal sync det and VRK det will indicate the break in the data transmission. And during the synchronous mode, the signal sync det and VRK det will indicate the reception of the synchronous character. I hope you have understood this whole idea, how 8251 actually works. Thank you.